Okay, friends, come on, let's get started. Okay, all right. So, once again, is my screen visible to you all? No, I don't think so. Is my screen now visible, friends? Good. Thank you. Thank you. All right. So, we're going to get started with this now. We will talk about microservices. Now, what microservices are, first of all, you need to understand what are services. So we have already talked about web services. We know what web services are. We understand that they are typically they are HTTP services. And when I say HTTP services, there are two types of HTTP services, two types of web services. One is the SOAP based service, and the other is which is completely XML based, and the other is JSON based services, which is as such known as RESTful services, right? So RESTful services is very much in vogue, and that's what is the de facto standard of developing any application today. So that's what we have. But these web services, they can be either when you develop a large enterprise application which is supposed to provide not one but n number of services. I hope you are all there with me, friends. All there. Very nice. So you've got to understand this very nicely. Microservices is the hot topic since last almost 4 years now. All right. I had done a huge consulting assignment for one of the uh, you know largest companies in US. It's a $5 billion company in Chicago, and I had done a complete consulting assignment end to end on microservices, giving them the proof of concepts of each one of those different architectural mechanisms that falls within the scope of architectural, microservices based architecture. So it's fun. I learned a lot over there, and then it will be fun sharing the same with you all here. So first of all, understand this. Instead of getting into microservices, first let's understand what if not microservices, and if it is there in vogue since 5 years or 6 7 years or so. I started working on it some 4 5 years back. So let me get the title here as microservices. So if not microservices, then how we used to develop our applications? We used to develop monolith applications. So the opposite of microservices is monolith, correct? Opposite of microservices is monolith. Voice is low. Is the voice low for everyone? So some of y'all are saying yes, some of y'all are saying no. Yes, lower than usual. And that's because I'm talking soft now, and the pace, I'll gather the pace. Don't worry about it. Okay. Hello. How is it now? Is this okay? Right. So you've got to increase the volume perhaps. Don't worry. Okay. Right. So it's early morning, isn't it? So yeah. So we talked about, okay, let me pull the microphone all the more nearer to me. Okay. So that should be good. Is that okay now? Is that okay? Is this okay? Yeah. Thanks. Okay, there is yet another way out. I can change this to. I think this will be better now because this will take the sound from every angle. Otherwise, it was only from one single angle. Okay, is it okay? Am I audible? One final time. Once again, am I audible now? Clear? Okay, come on, let's proceed. So, if not microservices, then what? Then what? It was all monolith applications. What do you mean by monolith applications? We used to develop applications which were modular in nature, no doubt about it. The applications were modular in nature. That means we used to create modules. And when it comes to modules, you see this, we have been developing applications here in our Spring Boot based applications here, whether it's Spring Boot or otherwise, whatever it is. We have created one project here, but to this project we can keep on adding modules. Let me give you an example of a modular application. Instead of me creating one over here right from the scratch, instead of that, let me pick up one of the projects from my own application. I mean, this is for one of our project. This is the project for one of our customers. And let me go ahead and projects, and it's one logistics. Yeah, and within that I've got code and I've got server side. Within server side, this is service. Okay, take a look at this, friends. Take a look at this typical project out here. Take a look. Can you see there is one parent project of my own? Take a look at this, friends. Don't miss this point. This is a large enterprise application which is developed for a very, very big logistics company. So you see this, I've got a parent application, and see I've got a pom.xml file here. This pom.xml file here, see the packaging type of this pom.xml file. This is pom packaging. I'm not creating a jar. I'm not creating a web archive, or I'm not creating anything else. It's actually a pom. What does this mean? This parent project that I have is meant only and only to provide the common properties, like over here, common properties. It's existing, it is provided so that, and I have created this parent pom project, not my words, parent pom project, so that I can manage the dependencies here, the versions of different libraries that I'm using here, so that I can specify all the modules that makes up this entire project. Can you see these modules? And within the modules, I've got all of these different modules here, friends. You can see this here, correct? And then, so this is my parent project, correct? This it's like, it's like having some common configuration done for multiple modules. Very simple. A parent project is like doing the dependency management, doing the properties, doing the versioning and all that stuff for all of these common versioning, common properties, common dependency for all the modules that forms that one single application. So you see this, I've got, OL parent, but then within that, all of these are different modules. If I click here and if I say file and project structure, and you can see this modules here, all of these are the different modules. Can you see this? Right? These are the different modules here. These are the modules. Can you see this? So this one single project has got all of these modules. I'll cancel this out and then back again over here. See, all of these are the modules. You can see this here. Okay. So we have modules here, and each module is in itself a library or a module. So you see this, I've got pom.xml file out here. You can see this for OL booking, or say I go to OL commons, or let me go to service consumer management integration, OL vessel, for example. Take a look. It has got its own pom.xml file. But what is the parent of this OL vessel? The parent is my own parent, OL parent. Can you see this? The parent is OL parent. Can you see this, friends? So this is my pom.xml file for OL vessel. So this is one of those modules within the project, and that module refers to its own parent, and the parent is com.im.ol. This is my own. You can see this parent project OL parent, and this pom.xml file. You see this when I go to this pom.xml file. What is the parent of this? The Spring Boot. You can see the Spring Boot parent. Can you see this here? 2.3.1 release version. All right. So this is how you structure your projects. You've got multiple modules. So this is definitely a modular application. So you used to create, and we used to create, and now also we create applications that are modular in nature. So this particular module will take care of all the services that are supposed to be supposed to be the part of this module. Then I have this another module. Then if I have this another module and then another module, each module will have components specific to the functionality that is supposed to be implemented in that module. And there are various different parameters based on which we decide that this is going to be a different module. And then see, given each module, can you see this? I've got, this is my base package. Within that, I've got controllers and services. Can you see this here? I've got controllers and services. This is how it is. Simple stuff. Got that? This is how it is. Now, so this is an example, right? This is an example. I will close this. So coming back here, We develop applications which are monolith in nature, correct? Large, huge enterprise applications with multiple modules in it. But when you assemble that entire application with all of those modules, it results into one single jar file or one single web archive WAR file. We call it WAR file, a web archive file. WAR stands for web archive. It is as same as jar, but it is just that it has got its own web archive file. Okay, let me take an opportunity here to explain to you some few more other interesting things here. You see this? This is the typical structure of your web application. I think it was. Okay, you remember Apache software, Apache Tomcat server that we had downloaded within that web apps folder, and within the web apps folder, you remember we had deployed our application. You remember servlet based application, the customer app application. You remember that? Okay, so in that you see this, any web application, a web archive file will be a zip file of an application which has got web-inf. Within web-inf, you've got classes folder which will contain all the classes that you have written. It will contain all the it will have a lib folder which will contain all the jar files that you have a dependency on. Correct. So just remember, this is the structure. This is the typical structure. You will have an application, and then you will have within that web-inf, within that web-inf, you will have web.xml file, and you will also have classes and the lib folder. These are the two most critical ones. Classes will contain all the classes that you have written in your web application. Lib will contain all the jar files that your web application is dependent on. Correct? That's how it is typically. And when it comes to Spring Boot applications that you have, note this, friends, you must make note of this. When it comes to Spring Boot application, for example, let's take a look at training. I say training. There is nothing in that. So why am I keeping it? Okay, so you've got trainings. You see this trainings within that PWC. You remember we created a Spring Boot application, and within that you've got a target, and within that you've got the jar file. You remember this jar file? Okay, I'm going to put this jar file in some folder called demo out here in downloads, and within that I am just simply copying this jar file. And now see the structure of this jar file. I say downloads. Okay, cd demo. See, this is the jar file that I have just dropped over there. All with me, friends? This is the same jar file. All with me? The same jar file. Okay, I'll say unzip spring demo.jar file. I'm saying unzip. The moment I say unzip, it unzips the whole thing. And please see this. There is a test. And I'm telling you upfront, I'm going to ask this question. In a WAR file, web archive file, you have web-inf within which you have classes and lib folder. Classes will contain the classes you have written in your application. Lib will contain the jar files that in other words, the library files on which your web application is dependent on. I hope you will remember this. In a web archive, when you explode a web archive file, in that you will find a web-inf, in a web archive, web-inf. And within that, you will find lib and classes folder. Classes will contain the list of all the classes that you have created in your application, whereas the lib folder will contain all the jar files on which your application is dependent. That is web archive. I have just exploded a Spring Boot based application. I have just exploded this jar file here in front of you. This is not a web archive, but a jar file. And you might have noticed that in case of a web application, we used to deploy our web application on Tomcat. See the difference. I am saying a servlet based application, we used to deploy that in a Tomcat application server. But in case of Spring Boot, we have Tomcat embedded into our jar file. See this? We have got embedded Tomcat. So when I run this, did I deploy this explicitly in some Apache Tomcat server? Did I do that? But it still started Tomcat. See, it's starting Tomcat. This is Tomcat. See, Tomcat initialized on port 8081. So this Tomcat is embedded Tomcat. I repeat, this is embedded Tomcat. In case of Spring Boot, there will be a test. In case of Spring Boot, there is embedded Tomcat. I repeat, there is embedded Tomcat in case of Spring Boot. And when you explode that jar file, you will not get a web-inf. You will not get a web-inf. You will get boot-inf. Please repeat, friends. What is it that you're going to get in a boot application? Boot-inf. And this boot-inf will contain classes folder and the lib folder. Same stuff. Classes will contain the classes that we have written. See our own application properties. You can see this PWC training. You can see this here controllers that we created, DO class that we created. See all the class files for the .java files that we have created, REST controllers that we created, services that we created. Come on, see this all there in front of you. Correct. And then you also have a lib folder out here. This lib folder contains all of those jar files on which you can see that Hibernate and everything else, you see, because we are using JPA. All of these jar files are the ones on which our Spring Boot application is dependent on. Correct? I hope you will remember this. Say yes. You will remember this. And you see, you've got Tomcat embedded here. Can you see this? Tomcat embedded core. So within boot application, boot-inf. Spring Boot application, boot-inf. But a web application, web archive, not that a boot application cannot be a web application, but a typical servlet based, non-Spring Boot based application, you will have web-inf. Okay, a typical J2EE based application or JEE based application will have a web-inf with a web archive file. So this is how it is coming back over here. So we used to come up with jar files or maybe web archive files which contains that web archive in turn. Why did I take you through all of this? Because that web archive, when you explode, it has got a lib folder within web-inf, and it has got those hundreds of jar files on which I have the dependency. My application has got dependency. Similar is the case with boot application. I have got boot-inf within which I have a lib folder in which there are all the jar files on which my code is dependent on. Correct? That's how it is. So how do I deploy that application? So we used to take up a server on the cloud, okay, typically on the cloud, of course. And I deploy my application here. Suppose that application is feeder. Okay, you may not be able to relate to it. Say a core banking application, right? Core banking application. So that core banking application is deployed here on this machine. This is that machine one. Okay, this is that machine one on which I have done the deployment. Correct. And of course, there is a limit to the capacity of this machine. How many users can concurrently be served by this machine? How many concurrent users? Maybe 100, maybe 200, right? Maybe 300 concurrent users. Suppose even if I have 32 GB RAM, if it's a 8 core or maybe a 16 core machine, then maybe, 100, 200, 300 customers, maybe 500 customers at the most, concurrent customers. But then as the number of customers, and as when I say customers, I'm sorry, end users. Forget about customers and end users, whether it's an end user or maybe some other application invoking the service. 500 concurrent requests. That's the best way to put it across. This machine may be capable of serving 500 concurrent requests. But if at all it goes on increasing, maybe there are more end users and more, there are maybe there are more a number of end client applications, some other kind of applications. And there are many such applications which are invoking services on this. That means there will be requests invoked on this application server. And if there are hundreds and hundreds of them, don't you think this machine will become slower? The response that will be rendered will be slower. There will be slower responses to the request if the number of requests go very high. Yes or no? Correct? For sure. That's how it is going to be. Correct? So, what do we do? What do we do? We used to have another machine in the cluster. We used to have another machine in the cluster, a full-blown machine with a full-blown operating system. Note my words, a full-blown machine with all the with all the machine is of reasonable size, 32 GB RAM machine, or maybe at least a 16 GB RAM machine with at least 4 core, at least, or maybe 8 core machine, and a full blown machine. right? And these machines are expensive on cloud, correct? So I will have to replicate yet another. The same application will be replicated on another machine. So how do I handle it? Maybe not just simply one machine. I have it on not just simply on two machines. Maybe I replicate it on three machines. Why? Because I want to serve maybe 3,000, 4,000 users concurrently. Now this same application is replicated across all the three machines. How does this work? I will have a load balancer. I will have a load balancer. What do you mean by a load balancer? Load balancer is typically either a hardware-based load balancer or maybe a software-based load balancer, wherein, if time permits, I will actually give you a demo of, or we may use load balancer while talking further about microservices. Correct? I've got load balancer. So what happens? You have your applications, browser applications, you have your mobile applications, and you've got hundreds and thousands of concurrent users, different browsers, different users using their browsers, different users using their own mobile application. Their request will land here, and here this is the load balancer on which the requests will land. It is this load balancer which is a smart load balancer, which identifies on which one of the three machines in the cluster. So this becomes your cluster, my dear friends. This becomes your cluster. So this becomes your cluster. I will put it over here, a cluster. What do you mean by cluster here? Plain simple English, cluster of machines. All right, cluster of machines. This is what a cluster is, isn't it? Yeah, a group, correct? So group of machines, cluster of machines. Yeah, very correct. So you have your external systems, which will in turn make a call. So the call will land where? On the machines directly? No, on the load balancer. Load balancer in turn will identify that the load is least on which one of these machines, right? It is least on this machine or it is least on machine 2. How is it? How which one of the three machine has got least load at that given point in time? That's what it will identify, and it will forward the request to that machine. You're getting the point? That's how it is. That's how it is. So all the user requests lands on the load balancer. Load balancer decides that which one of the three machines has got least load, and then based on that, now maybe there are various different algorithms, maybe load-based algorithms, or maybe weight-based. That's called weight-based algorithm, or maybe it is, well, weight-based is different, and then you have got just the round robin algorithm. That means the request that comes will be put over here. Next request that receives, it will be forwarded here. The next request that it receives, it will be forwarded here. This is called round robin algorithm of load balancer. So this is how typically a monolith works. So the entire core banking application, please note this point. The entire core banking application is deployed on one single machine. If you want scalability, I repeat once again, if you want scalability, if you want your applications to scale, wherein what do you mean by scalability? You want your application to be able to serve a more number of users. I repeat, you want your application to serve more number of users. If that is what you want, then in that case, you will have to increase the number of machines in the cluster. You will have to deploy that same application, replicate that same big monolith application, the entire application across all the machines in the cluster. You will have to do that. Now, this is very expensive in terms of money, in terms of maintenance. I repeat, this is very expensive in terms of money, in terms of maintenance. How is it expensive? Because as I said, this is a full-blown machine. I repeat, this is a full-blown machine. And this machine has got a full-blown operating system. So the cost of this machine, which is supposed to host a monolith application like core banking application, right? It is supposed to host that application, which is a full-blown application. It has got so many services to offer, right from messaging to emailing to sending an SMS and to do so many things, accessing the database and stuff and all. So many things it has to do. It has in it, right? Because one single large enterprise application will need many, many such external services, right? Right from database to mailing, emailing to SMS to this and that. Correct. So you create your entire your entire core banking solution into one large monolith application and you deploy it. So you need a full-blown machine. Also, you need a full-blown operating system, and you will have to maintain this entire machine. And then, if you want to enhance the scalability, if you want to have more people to be able to use your application, then in that case, another full-blown machine and an operating system on it, and then redeploy or replicate that application on this machine. I said it is expensive in terms of maintenance. Why? Because if there is a change in one small part of your application, I repeat, if you have a change in one small part of your application, you will have to redeploy that application across all the three machines. I repeat, you will have to redeploy that application across all the three machines. Am I right? This is what you will have to do. Correct? This is what you will have to do. This is called scaling at across x-axis. You can see this. This is x-axis. You are scaling across x-axis. So you will have to keep on increasing the number of machines. The maintenance is difficult. Each time you make a change, small change in one part of the application, you need to replicate that application across the entire cluster. What does that mean? Across all the machines in the cluster. And if and the machines are expensive, right? The time it takes to take the new features to the market is really very bad. It takes more time because you need to redeploy the entire thing, isn't it? Maintenance is really very difficult, right? So that's the problem. So what you do is that instead of working with and trust me, till date now also as we speak, there are millions of applications that are running on this architecture, on this deployment architecture. There are millions out there. So microservices is again not new. It's not happening, it has already happened. But the world is moving towards it. Companies, one organization to the other organization, they are moving on to it, right? Step by step. It's no joke. It's not easy. See, I'll tell you what, people say when see in your own organization, PwC, you may find not one thousands of applications running on different technologies. One may come up and say, "Oh wow, Scala is latest, super fantastic stuff, Scala." Right? Why don't we write all our applications Scala? Why don't Okay, new applications fine, but what about the earlier applications? What about the legacy applications? It's no cakewalk. It's no joke to migrate them to new. You will have to rewrite the large part of your application, and that rewriting is no joke. There has to be a business decision for it, and it is very expensive. Not only in terms of money, but expensive in terms of, I mean, it costs business good amount of time to do the migration, right, onto new technology, and that's not how businesses take decision. So unless their profitability is affected very badly because of a problem in the legacy system, they will live with the legacy system. Remember this. Because after all, they're into business. We love technology and we love to work on new technologies and stuff. Business, it's for them, they don't love technology, they use technology in order to serve their business needs. Always remember this. Correct? That's how it is. So you cannot criticize business because business will always, of course, see their numbers first. Okay, coming back here. So, maintenance is difficult. It is expensive in nature. So yes, companies now and the business stakeholders, they have understood that this is not a good way, the latest and the best way to deploy your application, to manage, to build, to design, to architect, to build, and to deploy your application must not be monolith applications. These are all monolith. This is one big monolith application, and the same application is replicated across all the machines. Instead of that, let's work with microservices. What do you mean by microservices here? First of all, let's take an example again of core banking application. Again, so this is monolith. right? This is my monolith application. Any doubts, any questions so far? Is the monolith concept crystal clear? And when you start working on your PwC projects, trust me, you will find many monolith applications there. Many monolith applications there. Any questions? This is clear, right? What is a monolith application? Because if you don't understand monolith and if you do not understand the problems with monolith, it's useless to talk about microservices. समजलं तुम्हाला? मराठी कळतंय तुम्हाला? इकडे या ग्रुपमध्ये कोणी आहे का मराठी? अरे वा, अभिजितला कळतं मराठी. व्हेरी गुड. Actually, I'm a Maharashtrian, born and brought up in Maharashtra. I relocated to Baroda some 8 years back. I'm originally from Mumbai, Andheri. Yeah, okay. Don't worry. Others can also feel at home. Those who don't know Marathi, don't worry. We're going to continue in English. So you see this here. You've got a core banking application. This core banking application is monolith. That's what we talked about. But suppose if you are asked to redesign or re-architect rather the entire application into microservices, so what you will do? You will start identifying. You will start identifying the services or a service which may have several endpoints, but they are logically related together and they are logically related to a particular business entity. Note my words. You will identify the endpoints. You know what are endpoints now? Come on, don't tell me you don't know what are endpoints now. Maybe I have not used that term with you all. You remember the customer risk controller? These are the endpoints. All of these are the endpoints. This is customer slash ID is the endpoint. Customers is the endpoint. Okay. And you remember we did configure over here. Chalo, the best way to show you the endpoints would be this. The best way to show you the endpoints is this localhost 8081 slash swagger hyphen UI dot HTML. See this customer risk controller, and you see these are the endpoints. Now you know what is an endpoint. You may call it an API or you may call it an API endpoint, whatever. So these are APIs, you may call them APIs, you may call them as endpoints, API endpoints, right? So this is the endpoint of this API, this is the endpoint of this API. So it's interchangeable, you know, we sometimes say endpoints, so when you have some set of endpoints which are very much related to a particular business entity, here in this case, come on, name the business entity that these endpoints are related to. Come on, I'll be very happy right there in front of you. Give me the name of the business entity that these endpoints are related to. Chalo batao. Yes, excellent. Customer, customer. Yes. Customer is the business entity. So in a real life application, something like a core banking solution, something like a core banking solution, don't you think that your core banking solution, now I will remove this from here and I will put it over here. Your core banking application that you will have n number of such business entities. So see this, you may have something like, right, okay, you will have something like, uh, what do you call it, say account, right? In a core banking application, see, when you are a member of any bank, I mean, you are a customer of any bank, you will definitely have account. And can't you have multiple accounts? Yes. So you are a customer to the bank and you can have n number of accounts. You can have one savings account, you can have two savings accounts, you can have In one particular account, you may be a joint member with your wife, with your mom, with your dad, and in another account that may be your sole account. One can be your salary account. So there can be several accounts. You are one single customer, but you can have several accounts. You may have a current account for your business, perhaps. Correct. So there is something called customer as well. So you have customer as another business entity. Correct. Then you have in a core banking application, you've got fixed deposit. So fixed deposit is yet another business entity. You're getting the point, right? And then can you think of something else? Yes, I can think of the transactions that you perform, right? The account transactions that you perform, you withdraw, you deposit, isn't it? So account, I'll say transaction, which is related to the account object, is also something that is there, isn't it? Account transaction. And there can be n number of, like, we do not belong to that domain, and hence there can be, we are unable to identify more than these services. Otherwise, there can be n number of, right? Credit card, why not? Yes, yes. You may have yet another service, another entity called credit card, right? Credit card. So, don't you think you will have create, read, update, delete for account? Come on, come on, come on. Yes or no? Don't you think you will have create, read, update, delete APIs for account? You will have create, read, update, delete APIs for customer. You will have create, read, update, delete APIs for account transaction. Similarly, you will have create, update, delete APIs for fixed deposit and credit card, then all the other business entities. And I'll tell you one more very, very important and interesting point here. You may think that create, read, update, delete are the only kind of APIs. No, 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 no. In real life, in business, you may have many, many APIs that would be quite specific to the business needs. For example, in case of a banking application, you have a customer. In case of bank, Access Bank, we ourselves, my wife, she had an account in Axis Bank, and after marriage, her name was supposed to be changed. And then when we, went to the bank and said, "You delete the account, right? Because in the PAN number, the name has changed. We will give you a new." They said, "No, we cannot delete. We can deactivate." That's a problem. Correct. You can deactivate. Anyway, so the point here is that in some businesses, you don't delete a customer. You can just deactivate a customer. Correct. So you have, you've got the customer account can be not just simply created, updated, deleted a customer object, maybe activate a customer, deactivate a customer, block a customer. If you have not, if your KYC is pending, they may block your account. So on the account, maybe there is a method, there is an API called block account. Come on, yes or no? Come on, yes? Block account, isn't it? Yes. Yes, that's how exactly. Yes, perfect. Block account. So these are the different, there can be different APIs with specific to account management, different APIs or endpoints specific to customer management, then different set of APIs, endpoints for account transactions, different set of APIs for fixed deposit and credit card, right? So what do you do? You say that I'm not going to develop this core banking application as one single large monolith application. You say that I am going to create one service. I'm going to call it a one single service called account service. So now what I'm going to do here is that I'm going to just simply keep, I'll just give better names to this from our architectural standpoint. I'll call this as account service. What does this mean? All the endpoints with respect to accounts management will be here. Then I will have accounts transaction service. And all my endpoints with respect to account transaction will be here. Similarly, I will have customer service. Okay. Here, since I'm just drawing a diagram, hence I can very well have spaces in real life. When you create a project, you better don't create a space. And then you have got a deposit fixed deposit service. Correct. So all the transactions, all the APIs that are with respect to fixed deposit will be over here. And then you also have something like credit card service. Now, when I say credit card service, or if I say account service, what do you expect? What do you think? You think there will be just one endpoint in it, or each one of these services as such can have several endpoints? What do you think? Come on, I'm waiting for an answer. Come on, what do you think? Tell me. It will have just one endpoint or several endpoints? Account service will have one endpoint or several endpoints? Yes. Very nice. Very nice. Excellent. Very good. You will have several endpoints. You will have many endpoints. All those endpoints will be create, update, delete, activate, deactivate, block, whatever. It depends on the kind of business logic that you want to implement, and the business services that you want to provide with respect to account service, with respect to customer service, but then I have a question to you now. Since you have understood how do we segregate the services, if I want to create a new fixed deposit for a particular customer, I want to create a new fixed deposit. So that API for creating a new fixed deposit will be in which one of these services? The endpoint or the API to create a new fixed deposit will be in which one of these services? Come on, fast. Aniket, how come account service? Yes, fixed deposit service, right? Right, fixed deposit service. So in order to create a new fixed deposit, whatever is the endpoint, now it's only the endpoint that you will put over here. So you will have a REST controller in fixed deposit. You will have an API created, a post API created for creating a new fixed deposit, and you will have the DAO. Sorry, first to start with, the service for creating a new fixed deposit where in account service, in customer service, credit card, or over here. These service, see, one is the REST controller, then the service, then the DAO, then the repository. So all of these, the REST controller, the service, the DAO, and the repository for creating a new fixed deposit, where would that be? All of these components will be where? Where will all of these components be? Tell me. In in the same fixed deposit service. Come on. Yes or no? It will be in the same fixed deposit service. Yes. The same fixed deposit service. Pretty good. Very nice. So, when I say fixed deposit service, don't you think we have learned Spring Boot? Otherwise, it's not necessary it has to be Spring Boot. This is architectural approach. Note my words. I am saying this is architectural approach. The implementation can be in Node.js, it can be in Spring Boot, it can be in Python, it can be in Scala, it can be uh, in what else do I know? Right? It can be in Ruby, right? Yeah, it can be in PHP. Yes. It can be in PHP. Any one of these. You got that? So the service implementation can be in anything. We are talking about Spring Boot. We are learning Spring Boot, and hence we are in .NET. Why do I forget Microsoft? .NET. It can be in .NET. It can be a C# based application. So for fixed deposit service, I will have one Spring Boot application, one Spring Boot application. Come on, yes or no? Which will have all of these. Which will have all of these what? All of these what? Come on. REST controller for fixed deposit, REST control service for business service class for the fixed deposit, the DAO class. Yes, all the components. Very good, Rakesh. Or you will have DAO classes for fixed deposit. You will have repositories for fixed deposit. Everything with respect to fixed deposit will be here in this Spring Boot application. Similarly, don't you think my credit card service will have its own Spring Boot application? Come on, yes or no? Hello. This will have its own Spring Boot application or not? Come on. Right? I'll use a smaller font size for it. It will have its own Spring Boot application. So here in this case, when I run this will be running in its own JVM. So my fixed deposit service is running in its own JVM. Don't forget about that. When I say a new Spring Boot application, it's a jar file. I did demonstrate that to you yesterday, friends. Haven't we run a Spring Boot application as a jar file all by itself? Come on, yes or no? Correct? Terminal. Okay, so cd, I'll say slash trainings, pwc, spring training. Okay, see this cd target. You remember this jar file? So this is my one single Spring Boot application which results into a jar file. Here you are. This is my jar file, and I will execute this as java hyphen jar and my jar file. Here you go. It starts. So this is my suppose fixed deposit service. It starts in its own JVM. Okay, because it's already running in my IDE and hence it says port is already in use, but I hope you're getting the point. Similarly, so this is running in its own JVM. Come on, correct? And then similarly, you will also have the card service running in its own JVM, correct? Because this is a different service, a different Spring Boot application. I hope there is no confusion at all in this. This is very clear. So far, so good. So far, so good, friends. Correct? Good. Very nice. So similarly, now needless to say that this is my one service, this is my another service, and similarly, I will have my customer service as well, isn't it? Come on. For the customer service as well, I will have what? What will I have? Come on, tell me. I will have another, yes, very good. I will have another Spring Boot application. Come on. I will have another Spring Boot application, and I'll say this is again a Spring Boot application, correct? And this will be running in its own JVM, correct? Make sense? So far, so good. Please, if you have any doubts, please tell me. If you have any doubts, please feel free to ask. Any doubts, friends? Just give me. Yes. So we can upgrade each. Yes, yes, Bharti. Very good. We can upgrade each one of these services. So I'll come to the. You are very right. I really appreciate that you have made that point. Out of all the benefits, this is one of those fantastic benefits that we have. So here you see, I will have yet another thing over here called I will in order to complete the Spring Boot application. Okay, Spring Boot application, and this is also another JVM. It will be running in its own JVM. Correct? See, so you have this with you. Perfect. And then similarly, you will have a Spring Boot based application for your account service as well. So these are the services. All of these other. So this is your core banking application, my dear friends. This is your core banking application. And there are, of course, not just simply these 5 services, but there will be a number of services. And this is your core banking application. So first and foremost, you've got to make note of this point that we have now, right? We have, yes, so Anand has got a point. Rather than updating the entire application, yes, Bharti. And we have different services running in the application. They have embedded Tomcat server. Each won't it create a load on the application? What load? And that's the point, Anand. In fact, thanks for mentioning that. Since it's a different JVM, how will it have load on another JVM? Come on. And one JVM is running in its own container. I'll come to it what the container means. So if suppose there is a lot of load on this account service, how will it adversely affect the other JVMs? There are different JVMs running on different machine here. Ah, yeah, load. In fact, you have distributed the load. That's the point, Anand. Hence, I said it was a good point. You have distributed the load. Say this 3 times to yourself. You have distributed the load. You have distributed the load. You have distributed the load. Correct? Now I will start one by one. I will start with the benefits out here. The benefits. First of all, tell me one thing. It is, of course, impossible to think of one single service in such an isolation that it will never ever need to access the other service. For example, while creating a fixed deposit, you will certainly need the services from customer, yes or no? Because your fixed deposit will always be created for a particular customer. Agreed? So the validity of the customer, getting the details of the customer will come from here. Yes or no? All agree? Come on, come on, come on, friends. All agree? Well, all agree, right? I hope you. Yeah. So you will certainly have a need to access customer service from fixed deposit service. There is a dependency here, friends. There is a dependency here. Come on, correct? There is a dependency like this. How will you access this? Because this is in one JVM, this is in another JVM. The service that you might have written in customer service application, in this Spring Boot application, you might have written something like customer service as a business service. You might have written customer DAO as a DAO class. You might have written customer repository as a repository. Correct? You might have written customer REST controller also, of course. Correct. So how do you think you will be accessing the services of customer? You cannot, because this is running on one JVM, this is running on another JVM. So there cannot be local call, right? I mean, I have a machine, I have my application running, Spring Boot application running on my machine. You have a Spring Boot application running on your machine. Can I invoke a service on your component from here? Does that make sense? Does that make sense? No. So how do you think this fixed deposit service will make a call here to customer service? Come on, come on, come on. Tell me through what? Come on, through what? One word answer. Yes. What about others? Rakesh says HTTP protocol. Is he right or wrong? Yes. It's going to be an HTTP call. HTTP call. Local. I mean, I'm just saying localhost, but I shouldn't be saying localhost. API dot. I'll say API dot, and I will write here. Say for example, pwc.com/customers, okay, /101. Suppose you wanted to get the customer details of customer which has got the ID of 101. So from here you make an HTTP call. You're like this api.pwc.com/customer/101. You got that? Now my point is this. My point is this. This is a Spring Boot application. I repeat, this is a Spring Boot application. Does it really matter to fixed deposit service that this is a Spring Boot application or a Node.js based application? Come on, come on, come on. I have a question. My question is, does it really matter to fixed deposit service that this application is implemented in Spring Boot or something else? Because it is anyways making an HTTP call. So this can very well be what? Come on. This can very well be what? Instead of JVM, can't this be Node.js based application? GS app. Come on, yes or no? This can be a Node.js based application. Such a big benefit. Such a big benefit. One particular team is working on this, another team is working on this. Two different things. They are related. There is a dependency, but that dependency is agnostic of which technology you have used in order to implement this service. Come on, yes or no? Yes, pretty clear, correct? That's one benefit. The other benefit is something that Bharti has already mentioned, and I think others also have mentioned. Especially Bharti mentioned that this particular service can evolve all on its own. This can be deployed all on its own. So it's quite possible that you have got a maintenance ticket. They see that this is the business logic that we have changed, or this is a new business rule that needs to be implemented while adding a new customer. Check for this. Some new enhancement request has come to you. Some change request has come to you with respect to customer. Do you think all the other services will be adversely affected? You will make a change only and only in this application. Come on, yes or no? Come on. You will be making changes only and only in this application. Come on. Getting the point. Isn't it brilliant? And tell me one thing, after making a change where you want to deploy that application, do you think you will have to redeploy? Unlike in case of monolith applications, do you think you will have to redeploy that entire application? Do you think account service will be affected? Do you think account transaction service will be affected? Do you think fixed deposit service will be affected? Come on. No. Absolutely not. So this can be maintained and this can evolve all on its own without having an adverse effect or without having any kind of an effect rather on the other services. This is yet another benefit. This is one big benefit. Don't underestimate this. Don't undermine this. This is extremely useful for business. Otherwise, earlier there used to be time, there used to be a good amount of time. Like for example, the releases. Now I'm giving you $1 million point, friends. $1 million point. Please listen. There used to be new releases after every quarter, or maybe even 6 months. If you really have very efficient team, at the most you will be able to do new releases, new features. You will be able to bring new features in the market after every 3 days. Sorry, after every 3 months, quarterly. But those days are gone. 3 months, if I tell my stakeholders that every 3 months only I will be able to come up with new releases, you give me whatever new application you've got, or maybe after every 15 days or what, they won't even accept 15 days. If I tell them that every 15 days, whatever changes you want me to do, I'll be able to deploy it. You ask me a change today, I'll be able to deploy it only after so and so time. This is my cycle, this is my process. No. Today it's all about CI/CD. Repeat. It is all about what? CI/CD, continuous integration, continuous deployment. CI/CD, continuous integration, continuous deployment, right? Yes. Continuous integration of the code of all the developers into release dev, and then the deployment to the QA. QA passes deployment to. Hello. Is it okay now? I'm not doing anything. I'm just talking. So how come? Maybe because of bandwidth or something. But I've got very good bandwidth. अभी ठीक है? Okay, thank you. So you see this. You have got continuous integration and continuous deployment. Today, the customers, Zomato wants to keep themselves ahead of Swiggy. Swiggy wants to come up with features as soon as possible. If they've got a feature in their mind, the business has got a feature in their mind. Oh, this is that new feature that we must add to the app. We will give this discount, or we will come up with a scheme and stuff and all. And then, we will be able to increase the sales. Now, before Zomato guys get that idea, you must be there in the market with that feature. Time nahi hai. Today, you ask your stakeholders, when do you want this feature? Your stakeholders tell you that these are the enhancements, these are the features. And if they ask you, if you ask them, when do you want this? They will say yesterday. What will be their answer? They will say yesterday. You got this? They will say yesterday. You're getting the point, friends. Okay, that's how it is. So, so this supports continuous integration and continuous deployment. You will not be forced to redeploy the entire application. So it's easier to deploy changes in one particular app and then deploy it. Correct? That's how it is. That's how it is. So this is one second benefit. The first benefit that we talked about is the first benefit that we talked about is what? There is no see in this monolith application. If you have decided for Node.js, then it's one big full-blown monolith Node.js application which you will have to replicate across all the machines. But here, each and every service, this is one service, this is another service, this is another service, this is another service, this is another. Each service can have its own implementation mechanism. It can have its own implementation platform. It can use its own specific set of frameworks. Very simple stuff. Correct? Very, very simple stuff. That's how it is. Perfect. Okay. Now another benefit. So yeah, so far so good. I hope there are no more questions. Is sir speaking? Yes, I am specking. So MicroServices are based architectural architect application internally use web service or communication, right? Of course. See, what do you mean by a web service? Any service that can be invoked over HTTP protocol is a web service. Yes. Yes. It's all RESTful APIs. It's all RESTful APIs. So this will expose RESTful APIs. This will expose RESTful APIs. This application can very well make a call to this another application with RESTful as a RESTful service, isn't it? Correct? Okay, now the third benefit. The third benefit here. Suppose, so where are all of these applications running? So one more thing before I proceed further. So this is one service, this is another service, this is another service. Each one of these services takes care of managing its own business entity. Note my words. It will take care of managing its own business entity, isn't it? So this is taking care of managing the business entity with business entity account. This year, the business entity management of customer, the business entity here is credit card, the business entity here is fixed deposit, and the business entity here is this. So these services manage a handful of endpoints, not all the endpoints. Here in this case, all the endpoints are into one single application. Here, handful of endpoints specific to account is in this application. Handful of endpoints with respect to customer service will be in this application. Handful of endpoints with respect to fixed deposit will be in this application. So I can now very well call each one of these as microservices. So this is one microservice, my dear friends. This is one microservice, correct? This is one microservice. Got this? This is another microservice. This is yet another microservice. And this is yet another microservice. And similarly, this is also another microservice. So all of these are microservices. Why do I call them, or why do we all, it's not that I call it, but everyone, this is how. Why is this a microservice? The reason is that it implements handful of it implements handful of yeah correct, it implements handful of endpoints. As far as the entire large enterprise application is concerned, it does not implement all the APIs slash all the endpoints of the entire application, but only and only the ones that are related to accounts, and the ones that are related to customer are here, the ones that are related to credit card here, and so on. So this is a microservice. So all of these are microservices. So I will say my entire architecture is microservices based. See the difference? See the difference here, friends? Correct? That's how it is. Microservices based. Pretty simple, isn't it? Come on. And you are going to work on this architecture for years to come, my dear friends. Please do not think you can get away with this. And why would you want to get away with this? This is a fantastic architecture, isn't it? Correct? It's fun. This is how it is. This is what you will be working on. More often than not, this is what you will be working on. Unless you are on an unless you are in some project which is a legacy application. There also you will get a lot to learn. It's always a learning. Never go with the impression of friends, I will work only on that, and I'm going to work only on this technology, and I'm going to work only on Java. I want to work only on JavaScript. I want to become a mobile developer. I want to be. Come on, guys, you all are engineers. Yes or no? What are you guys? And what do you mean by engineers? What do you mean by engineers? Can anyone tell me what is the meaning of engineer? Did I discuss this with you all on day one? What is an engineer? Engineer is the one who engineers. Acha, can do anything. That is also an exaggeration, I think. Yes, new things. Yes, Monisha. Okay, they can do anything. That is also, well, that's really good. But otherwise, engineering is creating new things. Engineering, you see this? Engineer. Who is an engineer? See this? Design and build a machine or a structure, modify and or by manipulating its genetic material, skillfully arrange for something to occur. See this design and build. Is it specific to, so if you are an engineer, you will be engineering products, you will be creating products, you will be designing and building products. That product may demand and depending on the demand of that product, depending on the business aspect of that product, you may decide to do it in any technology, or your stakeholders may demand from you doing it in any technology. Come on, you must be ready. It can be anything like Excel for that matter. A small application, you can develop applications in Excel. You know that you can do programming in Excel, and don't get stuck to one particular. So coming back over here, friends, you will see yourself working on the same architecture, throughout your career now as you move on. So let me group this up also, and let me group this up also. So these are all microservices. So we are now onto microservices. So as I said, the third big benefit here, and one of the biggest benefits, I would say, one of the biggest benefits, the cost. The cost. Okay. If I have to replicate a large monolith application, and if suppose this server costs me, suppose this server costs me, say for example, 5,000 USD per month, or say 5,000 USD per month, or whatever it's 5,000 USD per month, you will get a fantastic machine. It's never that expensive, but just, you know, 5,000 USD, suppose. And then you have, now again, it depends, if you really buy a full-blown server, then in that case, you see this pricing out here, you see AWS EC2 pricing. Here you see this, you're going to get the entire pricing here. Here you go. No, I don't want the calculator as such, but then, okay, I'll get you instance pricing. There is a list. Here it is. See, can you see this list here? Defined duration Linux. You see here now. You see this. This is from per hour cost. This is the per hour cost. A1 medium stuff and all. Right up to, you can see this. You've got M5 and large, and you see this. These are the machines. You can see this here. See these machines here, right? T4X2 large, and that is 0.0806 per hour dollar. That is almost a dollar an hour, right? You will end up paying good amount of money. And then you have right, if Windows usage, Linux usage, and then again it depends on which region you are purchasing it. All of that really matters. So this is expensive, right? So what you do is that, again, say 5,000 USD, and then again you need 5,000 USD for another. And if you wanted to scale further, again you will have another machine 5,000 USD, okay, and so on. Correct. One of my customers, they pay 17 lakh rupees per month for their entire AWS setup. They are a data company. They are a data company. They are into doing all the data related projects which are specific to AI and ML field. They collect the data and give to Google and Apple and Amazons of the world. So they do fantastic job. Their AWS servers, all in all, with load balancers and with AWS servers and with the database and with code commit and with code. AWS has got n number of services, my dear friends. AWS has got n number of services, right? All of these are the services of AWS. See this. I will certainly take you all through these services, a lot of them on the last day. Or maybe we get started even the day before, whatever, it depends. So see, this is yet another two-factor authentication wherein on my app, I will get a code which I'm supposed to enter here. And don't worry, even if you have seen this code, it will expire in next 20 seconds. So before you forget, before you figure out my password and stuff and all, it's of no use. So it's gone. So you see this is the recent one, and these are all the services of AWS. See all of these hundreds of services of AWS. Take a look. All of these are the ones which are very extensively used. So this is of one of my customers. There are 8 instances running. This is for one of my customers, right? It's their account that I have access to. See this. And there are so many load balancers here. You see this, all of these are the security groups that I have created. And then there are target groups for load balancing that we have created. Then there are load balancers that point to those target groups. You can see this, each one of these are load balancers. Got it. And these load balancers are configured. You see this, for example, this is the DNS name, and this is the load balancer that is configured with, like, for example, take this itself, for example. You see, this is a DNS name that is configured for this application. This is the front end application. This is exactly this. This application is pointing to that DNS, and see, so this domain name is mapped to that DNS. So all these, each and every request that goes lands on this particular, see this particular load balancer. You see this here. 443 is HTTPS, which in turn is mapped to this target. And in this target, these are the two EC2 instances, and these EC2 instances are the ones that is hosting the same application, and the load is balanced. The load is balanced. All right. This is through the load balancer, and this is what it is. You see, right? I get the data here and stuff and all. This is, there you go, isn't it? So this is the application that we have developed many years back. We're just maintaining it now. Okay, so see this coming back here. So if I have to scale over here, I have no choice but to buy new instances, correct? But as opposed to this, in case of microservices based architecture, if suppose you say that the transaction service is the most heavily used service in the core banking application. At the most, we create 1,000 new accounts in a given region. No big deal. At the most, we have 1,000 new customers created, and then 3,000 new accounts created for those customers, and then credit cards. Maybe we issue 3,000 credit cards on a daily basis, right? That's the business that we do. Still okay. Fixed deposits, we create some 1,000 fixed deposits in a day. Still cool. We have got, they say, 1,000,000 transactions done in a day. 1,000,000 transactions done in a day in that particular region, say India region. Now what? This one single machine on which we have deployed this will not work. So in the very first place, I repeat, in the very first place, I hope you are all there with me, friends. You getting the point? Right? Okay. So in the very first place, I have a question to you all. Do you think in order to deploy these services, you need a full-blown application service? Do you think you need a full-blown application service? No. You need lightweight machine. I repeat, you need lightweight machines. Virtual machines, not my words. You need lightweight virtual machines with the operating system on it just enough to run a simple app. Run my simple JVM of 500 MB approximately. That is what I want. See this machine. This is also a machine, right? This is a machine. Your mobile is a machine. There is an operating system on this machine. Is this operating system as powerful or as capable as the operating system that will run a large monolith application on your cloud? No. But this operating system is just powerful enough to run the apps. Come on, run the apps on this machine. Again, you know very well that if suppose you have bought a low-end phone, you will be limited with the number of apps that can run at the same point of time, and you will find that your machine is slow. But if you get a better phone with more RAM and more memory and stuff and blah blah blah, you will be able to run your apps much faster. But still, a machine. This is still a physical machine. This is still a physical machine. I'm saying in order to run this service, we need a virtual machine with an operating system just good enough to run my JVM, 500 MB ka JVM, right? A JVM of just 500, approximately 500 to 1 GB JVM, right? That's what I want. So in such a case, I don't need a full-blown machine, a full-blown operating system, a powerful machine. No, I need, in fact, these days, okay, when I say these days, it's not new at all. We have an architectural approach for deploying our application called containers. I repeat, called containers. So what I'm going to do now is I'm going to further expand this. See how our discussions led to, you know, expanding the stuff out here. You see this? I'll bring my this over here, and then this also is here. I'm going to bring this here. Okay, and then we have this service here. So this service, as well as this, each one of these services will run in its own Docker container. Docker is the technology which helps you to, on this machine of mine, on this physical machine of mine, I can start a Docker and I can create n number of machines on Docker, virtual machines. Each one of those virtual machines will be a machine by itself. I repeat, each one of those machines, virtual machines, of course, right? When I say virtual machines, not JVM virtual machine, I'm talking about the runtime, still so very similar. I'm talking about a container. Okay, it's a machine, actually a machine. Well, not, it's a virtual machine. Okay, well, I'm not talking about JVM, right? I'm talking about, okay, let me start bloody Docker here. Okay, you see, I do have Docker installed. You see this Docker, and you can see this now. It will tell me that the Docker is starting up. अरे ठीक है यार, ये देखो Docker start हो गया. You can see this Docker has started, and you see these images here now. So it says what are the container apps and Docker engine is starting up, and then you will find all the different images that are running. Those images are one images per container. Okay, so one Docker container is a machine by itself. Another Docker container is another machine. Another Docker container is another machine, and this is a machine on which you can install anything. You can install Node, you can install Java, you can, but not everything, because okay, if you do everything, then you need that kind of a Docker instance with that kind of memory given to it. Okay, so see, I have Cassandra running on this machine. Can you see this? I have Cassandra running on this machine. So instead of installing Cassandra locally on my Mac operating system, on Mac I have Docker, and on Docker I have Cassandra. You see this? Similarly, I can have anything that you think of today under the sun. You have a Docker instance, Docker image for it. For example, you remember we worked with Sonar. Sonar, you remember, friends? Sonar. Okay. So Sonar Docker. Okay. Sonar Cube on Docker. Here you go. Just what with this just one single command, I will be able to install, create a new container. Can you see this Docker pull Sonar Cube? The moment I now type this command on my machine, while Docker is on, it will create an image, it will download the image, the operating system, it will create a container, and it will install Sonar Cube, and it will start Sonar Cube for me. If time permits, on the last day, we will do this, my dear friends. We will do this for sure. Got that? So what I'm going to do is that, see, I have Docker, and I will quit Docker. So what the point that we are discussing is that each one of these microservices does not need a full-blown physical machine, does not need a full-blown complete EC2 instance or something. This can run in a Docker container, well, lightweight Docker container, the cost of which will certainly be far lesser as compared to this cost, as compared to the cost of a full-blown EC2 instance. So what I'm going to do now is I will create a Docker. Okay, I'll put this back. You can see this here. This is my, okay, जाने दो. I don't want to play with this, and this is just good enough. Yeah, yeah, alright, it worked. Okay, so this is my container. Can you see this? This is my container. I'm going to call this as container. What is this? This is my Docker container. Okay, this is my Docker container. Perfect. Super. This is my Docker container. So where is this application running? Come on, friends. Where is this application running? Tell me. This entire JVM, which hosts this entire account service, where is this running, my dear friends? Tell me, where is this running? This is running in a Docker container. Similarly, yes, yes, similarly, what I'm going to do is, let me, super, okay, this will be easier for me. So similarly, my accounts management, sorry, that was what, account transactions, right? Account transaction service. Okay, this is what it is. Accounts transaction service. This is my account transaction service. Correct? Perfect. This is running in its own Docker container. Take a look. This is running in its own Docker container. You got that? We are still on which point? The third benefit. You remember, please, let's not lose focus. What are we discussing, friends? We are discussing the third benefit. What was the first benefit? It is not dependent on which particular technology you develop a particular service. So this can, all of these can be Spring Boot, but then this can be Node.js. Correct. Second benefit that we talked about is that each one of these services will evolve all on its own. Correct or not? It will evolve all on its own. You got that? Any doubts in that? It will evolve all on its own. This will evolve all on its own. This will be deployed all on its own. Deployment of this will not adversely affect the runtime environment of the other services. The other services will still keep running. They will not have a downtime and they will not have any adverse effect. I hope this is crystal clear. You got this? Now, the third point that we are discussing is this, the cost. So if now you see that there are a million transactions in a day, I hope you are all there with me. This is the crux of the matter. If you say that there are a million transactions in a day, and this one single Docker container, of course, is not sufficient to host this, do you think you will have to cluster all the services? Do you think you will have to cluster the entire code banking application and put it in a different machine, or you will have to replicate or just increase the number of containers for account transaction? What do you think, friends? Come on, tell me. Come on, tell me what. So you have one Docker container here, you have another Docker container, and you have third Docker container, maybe three Docker containers hosting this service. You getting the point? The number of containers, yes. Correct. Increase the containers for the transaction service. Yes, super. Exactly. You will be increasing the containers only and only for transaction service. You will not be increasing the containers here. So the cost here is considerably less of scaling your application as compared to the cost of scaling here in your monolith application. You saw this third benefit, which is directly related to the cost, and this is really very, very this really is a big point for the stakeholders, for the business. Got this? This is what microservices is all about. Tell me if you have any doubts, any questions. If you have any doubts, any questions with respect to microservices. Okay, so now this is what I suggest. What's the time now? It's 10:57, almost 11. I will give you all 15 minutes to do the research work on this. I'm going to keep this open as it is in front of you, right? You see this here. And let me, okay, see this. So see this. This is what I'm keeping open in front of you, okay? Ponder over this. Take a look at this. Tell me if you have any questions, if you have any doubts, or else we will proceed further beyond this. So I'll give you 10-15 minutes to come up with questions or anything. 10-15 minutes for your tea break. At around 11:20, we are going to get back and we are going to get started. Okay, right, friends? Prepare yourself for the questions that you may have. Okay, I have to. There is one more task that is given by your, by your stakeholders. So I need to complete that task. So I will give you 30 minutes of time. So 11:30, we will be resuming back. I will complete that task. Okay, friends, 11:30, we're going to come back. All the best. Take care. Thank you.